Thanks, Ariadna. Great to be here today. As we were just introduced, we're Electrified Thermal Solutions. I'm Daniel Stack, co-founder and CEO and an MIT alum. We're decarbonizing industry with renewable heat, and we're doing this with technology that was about 10 years in the making, and 8 years of that was here at MIT. So the big challenge, that's the wrong button. Big green button. They try to make it obvious for you. The other green button. Fantastic. So we all know broadly what the big problem is. We need to run on zero carbon energy. How do we run industry on zero carbon energy? The good news first is we have really cheap renewable electricity, but it's electricity, and because it's renewable, it's intermittent. So we need to solve the storage problem, which is very expensive, and we need to solve the heat problem, because that's what industry actually needs, not electricity. They need constant, cheap heat. So our technology is the Dual Hive. We use the Dual Hive thermal battery to turn intermittent renewable energy into on-demand industrial-grade heat. When I say industrial-grade, I mean 1800 Celsius, hot as flames, downblend into whatever you need. We can do this much more cheaply than, say, hydrogen, and we can retrofit your existing process to decarbonize it. So the Dual Hive would sit, keep hitting the wrong green button. Dual Hive sits right here in the middle of the process between your solar farm, wind farm, nuclear plant, or just the grid itself that attaches to your site. We store that power and convert it into heat. We deliver it on demand to your industrial site at whatever temperature you need. And we can do this day or night by storing it when it's available and coasting overnight or when the wind is calm to your industrial site without you losing operation. And the innovation that enables these really high temps and really large scales that industry needs at a very cheap cost are electrically conductive bricks. This is what we were developing at MIT. Here's a few right here. I also have one in my pocket. I can show you later, but don't steal it. And essentially, we can stack up these conductive bricks into a circuit. Here's one little up and down here. We can zigzag that into any form factor we'd like of, say, a shipping container or a large tower or vessel and deliver hundreds of megawatts of heat at a very cheap price. And so here's sort of our shipping container first style product, but we can go up to the hundreds of megawatts and thousands of megawatt hours to suit industry's needs. And the main competition that Dual Hive is competing against is traditional heater options. So we developed these bricks to be very affordable, very high temperature, and very scalable, as you just saw. And this is really enabled by doing all this with oxide materials, patented oxide heating technology made from existing commonplace brick materials, essentially. Making those conductive was the trick, which is why we can have this big column of green features that we like to see. We compare that to competitors or other options in the electric heating space. You know, traditional metallic heater, your toaster wire, it's not hot enough for the hottest industries, and it burns out and needs to be replaced. When I say hot industries, I'm talking about cement, steel, glass, ceramics, chemicals production. Really high temperature processes won't be able to be done with metallic heaters. And if you look at the next step, ceramic heaters, traditional ceramic heaters you might see, it goes hotter. They're much more expensive. Their form factor is difficult to work with. They are individual rods. You don't want to have to install 20,000 heater rods in your system. It's challenging. And there's a few other options here. There's graphite, which burns out in most air or other atmospheres that industry uses, so it's hard to deliver that heat at high temps. And finally, we mentioned hydrogen. We are far cheaper than hydrogen because that chemical processing loses a lot, and the electrolyzers cost a lot as well. As for our first product, we're very early on, but our first product, which we're developing now and building our pilot of next year, is a 25 megawatt hour up to 5 megawatt output system that can put out anywhere from 200 to 1800 Celsius heat. It can run charge and discharge at the same time, so we can soak up the electricity, give it to you at your site. When it's not available, we can still give you your heat. And we can install more if you need, and you can always burn fossil fuels at your site or whatever your other heat source is when we're out of energy. So we don't take away your existing operating scheme. We did some economic analysis in the Midwest, for example, where there's a lot of renewable energy. We found that electricity was actually cheaper than natural gas half the time, which means we could save $250,000 a year and 5-year payback period or less in that particular region. The market is here today, and we can offset 80% of your carbon emissions, reduce them by replacing your fossil fuel needs. Basically, right now, this demonstration is being built in our system. This is to scale here. Shipping container is built next year as a product pilot, and from there, we'd be rolling out sales of this to hopefully your sites. So what we're looking for is industrials that have needs of really high temperature, really large systems, really large heat demands, anywhere from 1 to 1,000 megawatts. And we can do this in the iron and steel, cement, chemicals, glass, or other industries. And we are looking for folks that are interested in a first-of-a-kind demonstration and who are bullish on the energy transition and taking proactive steps. So please come talk to me if you're interested in learning more. Thanks.